All right. Hey everyone. Welcome back. Yep, we'll be starting our workshop today. So first up, we have Kevin Nilsson, DevRel engineer at Moonbeam. He will be sharing on building connected contracts with XCM. So yeah, if you have friends who haven't joined up, get them to join in. If not, don't worry. The session will be recorded as well, and everything will be posted on the Discord. So yeah, Kevin, take it away.
Oh, thank you so much, Elton. Much appreciated. And thanks everybody for joining us here today.
Uh,
I want to make sure
Kevin,
that
sorry,
yeah.
Kevin, you gotta step forward. Um,
Oh, step forward.
yes.
Got you.
Yeah.
Okay, how
Yep.
about now?
Yep.
Cool. Cool. Thanks everybody. I'm gonna keep a close eye on the chat, so feel free to drop any questions there. And yeah, love to talk about any questions that you have. And yeah, of course. We have a bunch of yes. Let me share those links a little bit closer towards the end. What would be the best ideas? We have some connected contracts examples, which I'll show. So let me just make a note. I'll show that a little bit closer to the end. Cool. Yeah, so thanks everybody for joining us. So you probably know a little bit about Polkadot already, but I think it kind of helps to kind of orient the rest of over the rest of my talk to kind of mention what Polkadot is and how it works. So Polkadot work on it was started, of course, in about 2015, 2016 by Gavin Wood, Robert Habermeyer, and Peter Zabin, and they took the approach. When it was actually not, the popular approach back in 2016, that the future was going to be multi-chain, right? The idea, the prevailing wisdom at the time was that, one or two chains would be able to scale and handle, the world's entire demand for block space in the realm of smart contracts. Now, obviously, that's something where even if you have the fastest, most scalable chain in the world, it's impossible to essentially have just one chain. And so they knew that the future is going to be multi-chain, and they said, well, how can we best build a framework in a blockchain environment that can handle this multi-chain world? And that's kind of where Polkadot arrived from. So Polkadot's architecture enables this multi-chain setup by having a relay chain, and the relay chain is the layer 0. It's the place where you're not going to deploy a smart contract or a game, but you're going to deploy a chain, right? And so if you're going to deploy a smart contract or a game, then you're going to choose a parachain to deploy to. And a parachain is just a fancy name for a layer 0. Yeah, let me know if you can't see. But I think you can just click on my screen and that'll expand it. Yeah, perfect. And the idea is that all these parachains will specialize in something, and they can provide unique features to the ecosystem. And when we say unique features, they could specialize in smart contracts, decentralized identity, storage, privacy, all these sorts of things. And the idea, of course, behind Polkadot is that they don't need to compromise for a general purpose environment. They can instead tweak and customize their chain exactly as they see fit, and tweak all the parameters so that their blockchain is very well suited towards their specific functionalities. But it's very important that Polkadot is not providing just a bunch of chains that are all kind of operating to themselves. That's not the idea. The idea is make sure that these chains are connected to one another and that they can talk to one another and share features, because that's where the interoperability and the benefits come from. It's not very interesting if you just have a bunch of chains which are kind of independent and not talking to each other. You derive the benefits once you can borrow and share features and things like that. So if your chain doesn't have IPFS storage, for example, but you can go to another chain that does, then perfect. And likewise for other features. So what is Moonbeam and where does Moonbeam fit in? So we started, Moonbeam launched in early 2022. The precursor to Moonbeam was Moon River on Kusama. And very importantly, it started by providing a fully compatible EVM and bringing that to Polkadot so that as a developer, you can build your smart contracts that you typically launch on Ethereum or Polygon or BSC, any other EVM compatible chain, and you can bring them over to the Polkadot environment very, very easily. And so how do we do that, right? And what does Moonbeam look like? So Moonbeam's built with Substrate, just like other parachains are. And so that this means that it is not it's not just a fork of the EVM, rather it's kind of a re-architecture and it's a rebuilt environment, which is 100% compatible with the EVM. But it's not just about providing an EVM. There's a whole layer of tools and support which are very important for you to have in order to replicate this same Ethereum developer experience. And so that includes things like a fully compatible Web3 RPC. And when we say that, we mean you can make a request like ETH get balance or estimate gas or ETH call, and you can make the exact same request that you would send to an Ethereum node. You can send that same one to a Moonbeam node. So you don't need to change the units. You don't need to change any of the parameters. You can send the exact same request that you'd make to an Ethereum node to a Moonbeam node. And so this means that integrating Moonbeam into your front end is very, very easy. And you don't need to overhaul your application in a major way. It's very easy to integrate with us. And Polkadot actually provides a framework called Frontier. It's an open source repository. And this is what allows Ethereum compatibility in Polkadot, essentially. It allows EVM compatibility, rather. And that's a major part, but it's not the only part. And this is important because if you just provide an EVM, you're missing a couple major features. And so part of that is the developer environment. You can't just provide the EVM and say, here you go. Rather, there's a huge amount of tooling that's built up around the Ethereum developer environment. So you have wallets, you have testing suites, you have frameworks, you have all different sorts of things that you come to expect on Ethereum. And if you're looking to launch on Moonbeam, and you're going to be expecting certain tools to be there. So it's very important that we have all those things, that we have compatibility with Hardhat, with Truffle, MetaMask, Remix, OpenZeppelin, and Tenderly, and many, many more. And this is very important to have these tools available. And it isn't a case where there's a huge amount of integration work that has to be done in order to support these tools. Rather, because of our seamless Ethereum compatibility, it's as simple as adding a new chain ID and getting the tool to list support for Moonbeam in their docs and in their application selector and stuff like that. And another important thing is that Polkadot uses a different account structure. So your typical Substrate account has a different private key. It has a different account length. And this presents an interesting situation. So if you want to interact with Substrate-specific features, such as democracy, or you want to do a balance transfer from the Substrate API, for example. When I say the Substrate API, right, there are two main ways that you can interact with Moonbeam. One is through the Substrate API, and another one is through the Ethereum API. So the Substrate API is accessing the Substrate side of Moonbeam, and that means you can access democracy, you can access the balances palette, you can access any of these other palettes similar to the way that you would access another Polkadot parachain. And then if you want to interact with the EVM, you'll use the Ethereum API. And this works exactly as it would with Ethereum. And so you can do things like ETH estimate gas and call and send a transaction and all of those things. So typically, in order to interact with both of those, you'll need to maintain two different types of accounts. You'll need to have a Polkadot account for the Substrate side. You'll need to have an Ethereum account for the EVM. And that's obviously not a great situation. So we built a unified account structure so that you can use a single Ethereum account and you can access both the Polkadot side and the Ethereum side. And that's very important for not just developers, but for end users, right? We can have users participate in governance without having to worry about keeping two different types of accounts. So we didn't just say, here's an EVM, have fun. We said, here's an EVM, have fun, but let's also provide some more features. And we did that in part with Precompiles. So I was just talking about the Ethereum API and how you can access all of the typical features that you'd like, whether you're sending a signed transaction, whether you're querying a smart contract. You can do all that through the Ethereum API. But being a Polkadot parachain, we also have the power of Substrate. And when I say the power of Substrate, Polkadot is an extremely powerful blockchain framework. So you can do way more than you can typically do. Inside of the EVM, you have access to a lot more capability with Substrate. And so that includes features like governance, staking, and XCM. And we'll talk more about exactly what XCM is in just a sec. But if you want to interact with these features of staking, of governance, and XCM, typically you'd have to learn about how they work, how they're implemented in Rust, things like that. And we wanted to say that no, you don't have to do all that. And so we made these features accessible through Moonbeam's EVM with Precompiles. So Precompiles are Solidity interfaces that we've built that enable you to access this powerful Substrate functionality directly from the EVM. So that means that you can access staking, you can access XCM, governance features, and more just by calling a specific Solidity interface. And so, for example, let's say with democracy, right? We have an interface called democracy interface dotSocial. We have a new one that's called conviction voting, actually, for Polkadot's governance 2.0. But we have applications such as PokeAssembly. PokeAssembly is a UI for voting, and that uses the conviction voting precompile, which has a bunch of different methods, but the key one is voting, right? And for voting, you have to specify, first of all, the number of tokens you want to vote with. You have to specify the lockup period for how long you want to lock up your tokens for. And of course, you have to specify the referendum that you're voting on and whether you're voting yes or no. And so all this can be presented and interacted with through this precompile. And in many cases, right, you might populate and present this transaction to an end user through a user interface. And this can be very simple for the end user. And it's also easy for the developer. It's easy for you to build and interact with. You just have to create the transaction according to the way the user has configured in the UI, right? So what I mean by that is for poke assembly, you choose the amount of tokens you want to lock up, the referendum that you're voting for, whether it's yes or no, and then how long you want to lock up your tokens for. And in the case of Polkadot's governance, you choose that lock period for whether you want to have no lock period or whether you want to amplify the impacts of your vote by locking up your tokens for a longer period of time. And you might interact with this just through the UI, but you also might have a smart contract, which also can call various different Moonbeam precompiles. So what do I mean by that? Well, one of the examples that we give in our Moonbuilders Academy course is that you might have a staking DAO, for example, and the staking DAO can collect funds, and the participants in the DAO can choose a collator to stake to, and then the smart contract can automatically go and call the staking precompile in order to delegate to a collator. So this is a big deal. This is very cool. Rather than it being like an end user, clicking and submitting a transaction, you can actually have a smart contract submit and interact with a precompile on your behalf, which is really cool. Of course, according to certain logic, you might have a threshold of when a delegation gets triggered, when a certain amount collects in the smart contract, or things like that. So in most cases, precompiles can be called not just by an end user, but also by other smart contracts, which is very cool. So I also want to talk a little bit about consensus and cross-chain, where Moonbeam fits in within Polkadot, and also where Moonbeam fits in outside of Polkadot. So from a high level, right? When we talk about blockchain consensus, a blockchain is a set of nodes, right? And these nodes, they can be block producing nodes. They might just be ones that are listening to transactions and independently verifying, the state of the chain. But it's very important that all of these nodes essentially be in agreement with one another, because if they're not, then we can start to have, maybe some problems. And what consensus is doing is consensus is kind of the way that we handle state transitions, meaning, somebody sends a balance transfer, somebody deploys a smart contract, or some sort of interaction happens, right? How do we agree whether that was a valid transaction or not? And essentially, you'll have a block producer. Essentially, you'll have a user, right, submit a transaction, and a block producer will, attempt to include that, and they'll make sure that it's valid. But we're not going to just rely on that one block producer. We're not just going to take it at face value. We are going to independently validate that that block producer has been truthful, that they've produced a block that's valid. And as part of that, it needs to have valid transactions that are within it. And likewise, if that block producer tries to do something that's fraudulent, maybe they try to change the parameters of a transaction and try to make it so that more money was transferred than was actually intended. That's something that can be very easily recognized, and it's something that can just be rejected by the rest of the network. So even if a block producer says, hey, this is what I want to include, this is the transaction, I promise, that's something that the rest of the network will easily pick up on if it's fraudulent, and they'll reject it. And so we actually have, that is kind of the general blockchain consensus. But what about when we introduce GMP protocols to the mix. And GMP protocols are very important and very novel and very interesting. They're just a way for blockchains to communicate with one another. So with general message passing, you can send a message to another chain. You can say, hi, hello. Typically, you're going to be doing more than that. You're typically going to be calling a smart contract on another chain. And one of these applications is, of course, bridging. It's not the only application, but it is one of the major ones. Cross-chain contract calls might happen as part of the bridging process, right? You could send funds and call a contract. You might send funds without calling a contract, or you might just call a contract. And another portion of that is that you may also be paying for gas on the destination chain. And so you may be sending funds for that. But something important here is that we now have two different consensus mechanisms, essentially. And how do we manage calls between these two blockchains? And one of the ways that this is done, and I'll present Axelar as kind of an example. Axelar is a general message passing provider. They connect Moonbeam to Ethereum, to Phantom, to Avalanche, to Polygon, and many other chains. And they actually have their own, they call it an overlay network. You can think of it as a little bit intermediary, sounds like a bad word, but intermediary is kind of what it represents, where you submit, let's say you want to make a GMP call from Moonbeam to Ethereum. You'll submit your transaction on Moonbeam. You'll specify how you're going to be interacting with the Axelar network, and your transaction will get picked up. It'll be confirmed on Moonbeam, and then Axelar will pick up that transaction. And when I say pick up, I mean the Axelar has its own network of validators, essentially, and they have about at least 50, between 50 to 100 nodes, and those nodes are running, they're actually running nodes across many different chains. So they'll be running, Moonbeam nodes, Ethereum nodes, etc. But in addition to those chain nodes that they're running, they're also running an intermediate consensus, which is essentially validating transactions and allowing them to be dispatched. So what I mean by that is if you're sending a transaction from Moonbeam to Ethereum, they're listening for the transactions on both sides, and they need to check a couple different things, right? They need to check that you have enough funds to pay for gas on the destination chain. They need to check to make sure that you're making a valid call. For example, right, Axelar supports many different chains, but if you tried to make a call on a chain that didn't exist or wasn't supported, that's something that would be checked at this intermediary step as well. So Axelar, and I'm using that in a generic case, there are other GMP protocols that behave in a similar manner as well. So they're checking to make sure, is what you're doing, is it going to be valid? Are you paying enough gas? Are you trying to send it to a valid chain? And if all these things line up, then it's going to do the most important step here, which is the Axelar network is going to approve it. So they're going to say, okay, this is valid. And then they're going to dispatch it onto the destination blockchain. So this is a really cool step. So they've got this cross-chain transaction, and we need somebody to actually send it on the destination chain. And so that's why they're running nodes for the destination chain as well. So it's very easy for this transaction to go ahead and get dispatched once it's paid for and once it's approved. So in the case of a cross-chain transaction, It's exactly like executing a normal transaction on the destination chain, but it's in case where it has to go between these hops. And of course, it has to abide by the rules of the destination chain as well. So if you are, for example, let's say you submit something that you know is going to fail on the destination chain, like it's going to revert, right? That transaction can get all the way to the destination chain, and then it can revert there. So what I mean by that is, let's say you have a simple smart contract which says, you know, it must be only allow this transaction to execute if we are past block, 1,000,000 in the future. So it's a million blocks in the future from where it is now. That transaction will get dispatched on Moonbeam. Axelar will look at it, and again, it's going to check to make sure that you have a valid destination chain, that you have that you're paying for all the gas, and that you're abiding by all the rules. But it's not going to check for execution on the destination chain. It's not trying to simulate that or approve it in the sense that it can still fail and revert, but it's making sure that it passes all of these cross-chain rules, and then it's going to dispatch it just like a normal transaction on the destination chain. So in that sense, cross-chain transaction is just like a normal one on the origin one. Yes, of course, I can share my slides. Yeah, let me share a link. Thank you for mentioning that. So you can access it at bit.ly/.apac. So that's DOTAPAC. And let me make sure that the sharing settings, cool, yep, anyone on the internet can view. Cool. So I think I was about here. So I was talking about cross-chain connected contracts. And I was speaking a little bit about, sending a message from Moonbeam to Ethereum via Axelar. One of the most amazing things about Polkadot is that Polkadot already has a general message passing architecture in place. That's called XCM, which stands for Cross Consensus Messaging, and it's already here. In essence, XCM is something that's available to every parachain. It's just something that has to be enabled and turned on. So the analogy that I like to give here is, imagine you've just moved into a new house. The cable and the internet and the power, all that's already going to your house, but you need to pay to turn it on. If you don't pay the power company or the cable company, even though the cable lines are going to your house, they're not going to let you use that power, right? So that's kind of the same thing with XCM, in that if you launch as a parachain on Polkadot, you have the ability to open up channels with all the other chains within Polkadot if you'd like and if you choose, and if the other chain agrees as well. So just because you want to open up a channel with another chain, that chain also has to agree. But one thing that's very important is that within Polkadot, right, you don't need to have some sort of separate consensus network like Axelar. Polkadot handles all of this because each chain is part of the same layer 0, right? This is important because if you have Moonbeam and Ethereum, for example, right, those are two different consensus mechanisms, two different sets of nodes, and two different blockchain ecosystems. But in the case of Polkadot, it's one blockchain ecosystem. And this is massive for security and ease of use. So you're never going to have a situation where parachain A thinks that one thing happened and parachain B thinks that something completely different happened. Because Polkadot is always going to verify and validate that one situation happened. And so parachain A and B are never going to be in disagreement because the relay chain is going to validate what actually happened. Yeah, and I think I just mentioned this, that let's talk a little bit about what XCM allows you to do, right? You can send a message from parachain A to parachain B. You might, so when we say message, it's really a series of instructions. And we'll look in a couple slides exactly how that works. But you might use the message to send funds. You might use it to call a contract. You might use it to do any arbitrary action. And importantly, whatever action you're taking and whatever you're doing, all this is being validated by the Polkadot relay chain, which is the same consensus, and which of course uses the benefits of shared security. Okay, so here, get into XCM. So XCM, I said, stands for cross-consensus messaging, and it's just a series of instructions. XCM is extremely powerful, and it's very open-ended. All it is a language. It's a language of instructions that you provide, which are, it seems a little bit, specific. So, and a little bit pedantic, or a little bit, very descriptive. And so the example that that Alberto likes to give here is, you might say to me, hey, go turn off the light here. And I can understand that that's simple, go turn off the light, no problem. But that's not what you would do within XCM, because there's many different languages and there's many different types of ways that you could say, go turn off that light, right? You could say, shut off the light. You could say, turn it off. You could say, turn the position of the light to 0. And so in order to have a environment that's more standardized and more clear, your XCM instructions are actually going to look way more descriptive than just turn off the light. So instead, you would say, if you're sending a message like this via XCM, you would say, Kevin, stand up, walk over to the light switch, press the light switch, and turn it off. And each one of those would be, instruction A is stand up, instruction B is walk over to the light switch, instruction C is turn it off, and then instruction D is like return to your seat. There are, a preset, formula essentially for how you would do different types of things, and how you handle different techniques and different actions within XCM. So if you want to bridge tokens, right, there are a specific set of steps for how you would do that, in terms of withdrawing the tokens from the origin chain and depositing them to the destination chain, and also paying for that to take place. And another example here is remote execution. Remote execution is, we're going to send a set of instructions from the origin chain to the destination chain to take some sort of action. And the action that you take, could be send funds, could be call a contract, could be do anything like that. And so Moonbeam actually has its EVM accessible via XCM. And this is a big deal where I don't think that I have a whole slide or a whole lot of time to talk about remote EVM calls, but it is the case where from another parachain within Polkadot, you can say, well, I'd like to interact with a bridge on Moonbeam, or I'd like to make a swap, or I'd like to call an oracle, which is really, really powerful. So from via XCM, you can interact with Moonbeam's EVM, and that's a major deal. It's the case where Moonbeam has allowed that action to take place, and it's a major deal to have the EVM accessible via XCM. So there are a couple of important features and things like that to kind of help us understand how XCM enables interoperability within Polkadot. There are a couple important concepts which we'll just kind of go over for a little bit. So one is the concept of a sovereign account. And a sovereign account is kind of exactly like it sounds. A sovereign account is an account that's owned by another parachain. Just as, if you have an embassy or you have if you have an embassy that's in another country, that is sacred, or it's a reserved land, that belongs to another country. It's a sovereign area. So a sovereign account is important because it allows you to do things like enable cross-chain transfers, and this works in a pretty particular manner. So to just kind of touch on how that works, right? Let's say that you want to make a transfer of, let's say, DOT tokens, right, from the Polkadot relay chain to Moonbeam, right? Moonbeam is going to have a sovereign account on the Polkadot relay chain. And so when you want to transfer your DOT from the relay chain to Moonbeam, what you're actually going to be doing is you're going to be sending your DOT from your account that was on the Polkadot relay chain to Moonbeam's sovereign account on Polkadot. So Moonbeam essentially controls this sovereign account, which is on the Polkadot relay chain. So it's on another chain, and Moonbeam will recognize that you made this deposit. It will be able to see that, okay, you sent 2 DOT or 5 DOT or 10 DOT, whatever it was. It will see that you sent it to Moonbeam's sovereign account, and it will be able to credit you with an equivalent amount of what we call XC DOT, which XC DOT is just an ERC20 form of that native DOT asset. So you're taking your DOT from the Polkadot relay chain, and now you're going to get XC DOT in return, which is an XC20, and you can do all sorts of things with it. You can put it into DeFi, you can swap it, trade it, do all sorts of cool things, and that's enabled by the XC20 capability of it, which means that you're taking a substrate asset and you're putting it into the form of essentially an ERC20. And not even, no compromises here. It is 100% compatible with the ERC20 interface. This is something that's really, really cool. So it's a substrate asset, which means you can transfer it via XCM. So it's very friendly within Polkadot, but then it also conforms to the ERC20 interface, meaning that all of the methods that you can call on an ERC20, you can call on an XC20. So it's a very, very interesting asset in that sense. So I think I actually kind of hinted at this a little bit earlier. If you're making a transfer, right, of DOT, and I think I spoke about it in the context of the relay chain to a parachain, right? But we can also think of it as, sending from one parachain to another parachain. You're going to be sending those tokens on the origin chain to the other parachain's sovereign account, also on the origin chain. And those are going to remain there until somebody sends them back, right? So the destination chain is going to credit you with tokens, and it will allow you to do whatever you want with those tokens. And let's say you swap them, right? You trade them, somebody else has them. Then if they return them to the origin chain, then they'll get unlocked from the parachain's sovereign account, and they'll get released to you on the original chain. You meaning whoever has made the transfer. They don't go back to the original transferer. They'll go back to whoever has essentially bridged them back. There are a couple of different steps here. One is, which we can, I kind of want to call attention to a couple different steps, but one is that while you're making this transfer, right, it's making privileged calls, and it's important that the exact instructions get executed, at the appropriate privilege level and no higher. So at a certain point, after privileged actions have taken place, we're going to clear the origin. Essentially, let's say imagine you're running in sudo, right? You only use sudo for a very important command that I'm saying sudo like in the Linux sense, not actually Polkadot sudo, because Polkadot does have a sudo, but that's typically only used for testnets and development purposes. So let's say you're in Linux sudo mode, right? You're only going to stay in that mode for however long you need to take the extremely privileged action. Once you no longer need to take the privileged action, you want to exit out of sudo mode because you could get into trouble and things could go wrong. So we use the clear origin instruction to ensure that we are not taking any extremely privileged actions. And so that the origin of the call is correct. Okay, and another important instruction with XCM is that we are always going to be paying for our execution. XCM has what's called the XCVM, or kind of like the XCM virtual machine. And the XCM virtual machine can process these instructions. And just as you would pay for gas in the EVM, you need to pay for the execution of these instructions. And you're going to be paying in terms of picoseconds of execution time. And you're going to be paying at the point of submitting this, at the point of submitting your original XCM transaction. So what I mean by that is from the origin chain, you're going to say, set aside some tokens to pay for this cross-chain XCM transaction. If for some reason you run out, right, the execution of your XCM message will just stop, and it will not, achieve the desired outcome. Excuse me, I have some allergies. If, for example, it can also work the other way. If you provide too much gas, right? If you provide too much in terms of funds, here, just give me 1 minute. I just want to blow my nose. If you provide too much in funds, right, you can actually do one of two things. You can just say, forget about the extra funds, I don't care about them, or you can actually call for a refund to get them back. Okay, and this last step here, if you're making a remote transfer of sending funds from one chain to another chain, the last instruction that you're going to give is to actually deposit that amount on the destination chain. So in this case, Bob is getting his XC tokens. This could be any sort of asset from another parachain or from the relay chain. And he's getting these assets on the destination chain, and he can do whatever he'd like. So I want to skip ahead just a little bit. I want to be conscious of time, and I want to allow a little bit of time for questions. So I'm just going to speed ahead just a little bit. Okay, cool. You heard me talk a little bit about XC20s, right? And why they're so cool and why I was so excited about them. So XC20s are ERC20 compatible assets, which you can interact with through the Ethereum API, through an ERC20 interface. But under the hood, these are substrate assets that can be transferred via XCM. And so this allows you to take, the dot asset, which is a substrate asset, and it allows you to put it into DeFi. It allows you to yield farm, stake, do all sorts of cool things, including liquid staking and many other possibilities. But that's something that I wanted to point out. I also wanted to point out here that Moonbeam is super well connected within Polkadot and also outside of Polkadot. So we kind of have this dual approach where within Polkadot, you can use XCM to call contracts on other chains. You can use it to send funds to other chains, to bridge assets, to do all different sorts of things. But we're also super well connected to chains outside of Polkadot as well. So outside of Polkadot, we use GMP providers such as Axelar, Hyperlane, Layer Zero, Wormhole, and many others. And what's cool about that is that once you're integrated with a GMP provider, such as Axelar, Axelar is pretty consistently, and these other GMP providers, they're very consistent in adding support for new chains. So they may say that we are going to, choose a new, we're going to provide support for a new layer 2 or a new app chain. And because of that, Moonbeam then gets access to this new app chain or this new layer 2. There's no sort of integration that needs to be done. There's no sort of extra support that Moonbeam needs to add. This is something where we're connected to Axelar, and Axelar is connected to this new chain. Therefore, Moonbeam is connected to the new chain, and so that's really, really cool. So going back to Jamal's question for XCM sample code and cross-chain connected code and things like that. One of the things that we have is this GMP sample DApp. So I want to share that with you. So that's so that would be the hello. Let me see. Here we go. We call it the Moonbeam multi-chain demo here, and I'll share a link to it right here. So this is one, and so just as an example, I think you can still see. Cool. So this is using a connected contracts approach. If we want to send a message, hello APAC.hackathon, we can send a message from, let's say, Moonbase Alpha, and I just need to unlock my MetaMask and switch it to the right chain. We can send a message to Avalanche, for example, and I just need to confirm it in my MetaMask here. Excuse me. We'll come back to here in just a second and check on the status. But essentially, we're sending a simple hello world message. In most cases, you're going to be actually calling a contract to take a particular action, right? We can see that the transaction was successful here on Moonbase Alpha. And I'll come back here in a minute and we'll check on the cross-chain status to see how the execution went. We also have, we do have a bunch of XCM related examples as well. So I'll share those. I'll hang around here after the presentation and I'll share some of those additional links as well. So I also want to talk a little bit about the bounties because of course, that's the focus of the hackathon, is working on projects and bounties. So our big bounty is, we would love to see you build a connected contract with Moonbeam. A connected contract just means that you are calling a contract on a remote chain and hopefully using it, to do something interesting and cool. We have a number of prizes here. We have a first place prize of $5,000, a second place prize of $2,000, and $500 runner-up prizes for 3 additional runner-ups. And if we think about ideas here or what you might do or things like that, one good source of inspiration is you could take any sort of dApp that already exists and you could try to make it cross-chain. And what do I mean by that? Well, one example is you have an NFT marketplace, right? And the NFT marketplace is on a single chain, buying, selling, bids, whatever. If you were to try to make that cross-chain, that would be like 10 times more powerful in terms of features and functionality. So you could have an NFT marketplace on Moonbeam, and you can have sellers, list their NFTs on Ethereum. And once somebody buys that NFT, right, they'll buy it on Moonbeam, but then the transaction to actually transfer that NFT will take place on the origin chain of Ethereum. And so this is a case where the user never has to go to Ethereum. They don't need to bridge funds or get new gas tokens or anything like that. But Moonbeam behind the scenes would be orchestrating this cross-chain transaction. So I just kind of thought that that's kind of one way to think about brainstorming cross-chain connected contract ideas. And here we go. So our cross-chain transaction just succeeded. Let me share that here. So we got a transaction hash on Moonbase Alpha. We also got a transaction hash on Axelar Scan. So if I just go to testnet.axelarscan.io, and I'm going to share this as well, we'll look up our transaction hash here and see what's going on. So we saw that the source was Moonbase Alpha. The destination was Avalanche. We can see the transaction hash on the origin. We can see that we paid for gas on the origin. We are sending along some funds. Now this is testnet, so the amounts here are going to be higher, than what you'd see in real life. But we're paying for the transaction to take place on the destination chain. We can see that it got executed here. We can go ahead and click on it and see what's happening there. But if we also see the payload data and the execution data, I'm going to head to the Avalanche Explorer here, and you can see what happened. If I switch around this input, we can see here that I have hello apac.hackathon. So this includes the message that I was sending, and this would be this arrived at the contract that we have here. That was just the hello world, receiver contract. Yeah, so that brings us pretty close to the end. And I want to invite you to check out docs.moonbeam.network. So that's DOCS, docs.moonbeam.network. We have lots of resources there, and I'm going to share a bunch of those links here, and I'll also stick around, to answer any questions. And thanks so much for your attention, and thrilled to see a bunch of people here. I really appreciate that.
I think we have a question from Jamal. A couple of questions
Oh,
from
yep,
Jamal.
great question. So faucet.moonbeam.network, that will deliver dev tokens. And another important link is we have this Moonbeam swap, which this is for getting cross-chain tokens. So if you want to play around with XCM and stuff, then you can swap to this XC unit token if you'd like. Swap to XC unit. And that is essentially like the dot within the testnet, right? So yeah, you can use that. You can swap it around. Oh, great question. Are there any minimum requirements for what counts as a connected contract? The example you shared, yeah, exactly. That meets the requirements for sure. So the minimum requirement, right, would be that you're sending a message from Moonbeam to another chain, or you're sending a message from another chain to Moonbeam. And ideally, you would take an action based on that message, right? You could say hello world, you could send a message, you could say hi, hey, hi, but ideally you would be sending, a contract call. So in this hello world contract, we are interacting with a contract. We're just storing a message, right? But instead of storing a message, you can call any contract. That's the most powerful thing about cross-chain contract calls is you can call like the Uniswap. You can make a swap on Uniswap or any other DEX. It doesn't need to be a special cross-chain contract that you ultimately call, right? You can, as long as you provide the call data, the contract you want to interact with, and everything like that, you can interact with any normal smart contract, which is really cool.